We're going to start this unit by looking at rational expressions. So before we talk about expressions, let's just recap what a rational number is. So a rational number, so it's the quotient of two integers. So integers, those are your positive counting numbers, your negative counting numbers, and the number 0. So the quotient of two integers, and the denominator cannot be 0. So I have 4 rational numbers written here, so 4 over 3. Both the numerator and denominator are integers. Negative 1 over 7. We have an integer in the numerator and denominator. 0 over 2. Integer in the numerator and denominator, and of course this would typically just be simplified to 0, but could be written as 0 over 2. And then finally we have negative 6, and realize that even though we don't write it, this is an equivalent expression to negative 6 over 1. In fact, it's a simplification of negative 6 over 1. So those are all rational numbers. Let's go on to rational expressions now. So a rational expression is an algebraic fraction, and the numerator and denominator have to both be polynomials. So what are polynomials? Well, there's a number of different types of polynomials. We have constants, we have linear functions, we have quadratic functions. So all of these have x raised to some power. So in this case it's x to the 1, x to the 2. 1 would be the same thing as 1 times x to the power of 0, and so forth. So here are some rational expressions. 1 over x, so both 1 and x are polynomials. C over c minus 1, so c is a linear polynomial, c minus 1 is a linear polynomial. 2r squared over 3n squared minus z. So we have a quadratic polynomial in the numerator, we have a quadratic polynomial in the denominator, even though it involves multiple different variables and not just the same variable. And we have 2. And as we looked back at rational numbers, this is the same thing as saying 2 over 1, and we would consider both 2 and 1 to be polynomials. They're both constants. Okay, so final thing to wrap up here is non-permissible values. So it's anything that would make the expression undefined. So if you recall, for rational numbers, we're not allowed to divide by 0, so the denominator cannot be equal to 0. So non-permissible values would be any values that make the denominator of a rational expression equal to 0. And we'll see as we get further into this that you must make sure that you go back to your original unsimplified expression to look for some of these non-permissible values. So let's start by looking at a few different rational expressions, and we want to state any restrictions on each of these rational expressions. So restrictions would be values which would make our denominator equal to 0. So we have c minus 1 in the denominator. We have to make sure that whatever value c is equal to does not make the denominator equal to 0. And we have c minus 1 equals 0. If we add 1 to both sides, that tells us that c cannot equal 1. So this would be the non-permissible value for this rational expression. So we're not allowed to have a c value equal to 1, because if we did, what would that do to this expression? So if c was equal to 1, then our expression would be 1 over 1 minus 1, which is equal to 1 divided by 0, and division by 0 is undefined. So that's why we need this restriction to ensure that when we substitute in values for c, we do not get a value which induces division by 0. So our non-permissible value is c cannot be equal to 1. Alright, so our second rational expression involves r, n, and z. So we have multiple different variables at play here. Now, similarly to the previous problem, we are not allowed to divide by 0. So we need to ensure that this denominator is not equal to 0. We're not going to get a single non-permissible value like we did in the previous example, but we're going to have a range of non-permissible values because n and z could be different combinations. So this statement is true for a restriction, but typically we'll want to solve it for one of the two variables. We're not given guidance in this case about which one we want to solve, so I'm going to isolate z. So what is our restriction? 3n squared is not allowed to be equal to z. Now realize that this is going to give us a large range of solution pairs which are not valid. So for example, if n was 0, 3 times 0 squared would be 0. So here is one non-permissible pair. So if n is 0, z cannot be 0. If n was 1, 3 times 1 squared would be 3. So if n was 1, z could not be equal to 3. So here are some non-permissible pairs. Now, we don't have to list every pair, and that's a good thing because there's an infinite amount of those pairs. But this expression will generate every possible non-permissible pair. So the restrictions in this case would be 3n squared is not equal to z. That tells us all of the restrictions for n and z. Alright, so let's take a look at a few more that only contain one variable now. For our third expression, again, we have to ensure that the denominator is not equal to 0. So that tells us that z plus 2 times the expression z plus 3 cannot be equal to 0. So we have two possibilities. If we're multiplying two numbers together, that could give us 0. One possibility is z plus 2 cannot be equal to 0, which means z cannot be equal to a negative 2. The other possibility would be that z plus 3 cannot be equal to 0. Therefore, z cannot be equal to a negative 3. So there are two restrictions. Z cannot be equal to negative 2, and z cannot be equal to negative 3. Alright, our final problem for restrictions. So 1 divided by x cubed minus x. Before we go any further, let's factor the denominator as much as we possibly can. So looking at this denominator, I see there is a factor of x. So we're going to factor x out of the denominator. So if we have x cubed and we factor out an x, we're left with x squared. And if we have x and we factor out an x, we're left with 1. So this is equivalent to x times x squared minus 1. Note that x squared minus 1 is the difference of squares. So this one will factor further. So this is 1 times x plus 1 times x minus 1. So what are the restrictions? Well, we know that this denominator is not allowed to be equal to 0. We have three different factors. If this first factor was a 0, then our entire denominator would become 0, which is not allowed. If this second factor was a 0, which will happen when x is equal to negative 1, then our entire denominator would once again become 0. And finally, if this third factor was 0, then our denominator would become 1 as well. Now you will often see all of these non-permissible values written in the same expression, and we typically go lowest to highest if we're doing that. So x cannot be equal to negative 1, or 0, or 1. Okay, in the next video, we're going to look at taking rational expressions and simplifying them as well as listing non-permissible values.